This video is about using properties of quadrilaterals to solve for a missing variable. So our first shape is going to be parallelograms. So the properties of parallelograms. From our definition yesterday, we know that the opposite sides are parallel. Remember that these arrows mean parallel, which means that the lines are never going to intersect even if we extend them. The opposite sides are congruent, which means they're going to have the same length. The opposite angles are congruent, so the top left and bottom right, and then the top right and bottom left are going to be congruent. They're going to have the same angle measurements. Your diagonals bisect each other. So one diagonal is going to be bisecting the other. It does not mean the diagonals are congruent though, especially because our parallelogram is a little bit slanted. And the last part is any pair of consecutive angles is supplementary, which should make sense because if we have parallel lines, these are same side interior angles. So let's use these properties to solve for variables. So in number one, we want to solve for x and y, and we want to find the perimeter. So in this case, in our parallelogram, our opposite sides are going to be congruent to each other. So we have 10x minus y is equal to 22 plus 3y, which we can change this into 10x minus 4y equals 22. And then we have 6x plus y is equal to 4x plus 8. So we get 2x plus y is equal to 8. Using those two equations, we can solve a system. So we have 10x minus 4 equals 22, and we have 2x plus y is equal to 8. So I'm going to multiply the second equation by 4. 10x minus 4y equals 22, and 8x plus 4y is equal to 32. So when we add straight down, the y's cancel out. We're left with 18x is equal to 54, which means x is 3. Once we know x is 3, we can go back and solve for y. So 10 times 3 minus 4y equals 22. 30 minus 4y equals 22. Negative 4y equals negative 8. So y is 2. So we would have 3, 2 as our ordered pair. If we need to go back and find our perimeter, I can substitute my values in. So 4 times 3 plus 8 gets us 20. So we know the opposite sides are both 20. And then we have 22 plus 3 times 2, which is 28. So we know both opposite sides are going to be 28. So our perimeter is 28 plus 20 plus 28 plus 20. So when we add those together, we get 96. Number two, solve for x and y. So we know that our opposite angles are going to be congruent. So we have x squared minus x is equal to 110. We can move everything to the x squared side. So x squared minus x minus 110 equals 0. Two numbers that multiply to negative 110 and add to negative 1 are going to be x minus 11 and x plus 10. When we switch our signs, x is 11 or negative 10. Both solutions would stay. Then we're going to do the same thing for y. So y squared plus 3y is equal to 70. We can subtract 70 over. Y squared plus 3y minus 70 equals 0. So we need two numbers that multiply to negative 70 and add to 3. So we would have y plus 10 and y minus 7 is equal to 0. So y is negative 10 and y is 7. In number 3, these are diagonals. So remember the property with diagonals is that the diagonals bisect each other. So we would have 9x plus 44 is equal to 6x plus 68. So we get 3x is equal to 24. When we divide, x is 8. We also have 4y minus 6 is equal to 2y plus 40. 2y is equal to 46. So y is 23. Our next shape is a rectangle. So a rectangle has all of the properties of a parallelogram, and then it has some special properties to itself. So the other properties that are special to a rectangle is that all of them are right angles. Because of this, now our shape is not leaning anymore. So all of our diagonal pieces, because they were bisected and now they're congruent, all 4 pieces of the diagonals are now congruent. So remember to use your parallelogram properties because a rectangle is a special type of parallelogram. So those other properties still come into play. So number 4, we want to find all of our angles. So if we know that this angle is 22 degrees, when I subtract from 90, I get this is 68. Now, if we use alternate interior angles, we know that this angle is going to be 22 degrees. Remember that our diagonals are bisected, so they're creating isosceles triangles. We have 2 isosceles triangles then, 2 types. We have one type with the 22-degree angle, and we have one type with the 68-degree angle. So we know that these are both 22 degrees. Same thing on top, because our top and bottom triangle and our left and right triangle are going to be the same. To get the middle angle by E in the blue triangle, we can subtract 22 and 22 from 180, so we get 136 degrees. In the yellow triangle, we know that both angles are going to be 68, which if we use alternate interior, will be the same in the other triangle. Then we can subtract that from 180 to get the remaining angles are 44 at the center. In number 5, we want to solve for x and we want to find AC. So AE is 3x plus 5, BE is 6y minus 1, and EC is 17. Remember we said that the diagonals bisect each other? We also said that the diagonals are congruent to each other, which means all 4 pieces are congruent. So if one is 17, they're all going to have a length of 17. So to solve for x, 3x plus 5 equals 17. We can subtract 5, 3x equals 12. When we divide, x is 4. We can also solve for y, 6y minus 1 equals 17. Add 1, so 6y is 18. Divide, so y is 3. Last, we also want to find the length of AC. Well, we know that AC, each part of the diagonal is 17. So AC is 17 plus 17, which is 34. In number 6, we have opposite sides. So opposite sides are congruent. 2x plus 4y is equal to 24. We also know that the angles are a right angle, so we have 12x plus 6y equals 90. Now, in order to solve, we need to multiply one of the equations. So I'm going to multiply the first equation by negative 6. So I get negative 12x minus 24y is equal to negative 144. And then we have 12x plus 6y is equal to 90. So when we add straight down, negative 18y is equal to negative 54. Divide, so y is 3. Once we know y is 3, we have 12x plus 6 times 3 equals 90. 12x plus 18 is equal to 90. 12x equals 72. So x is 6. So this would be 6, 3. Our next shape then is a rhombus. A rhombus is also a special type of parallelogram. So in a rhombus, we have all of the properties of a parallelogram, but now we also have some special properties of a rhombus. All sides are congruent. So not only are the opposite sides congruent, but now all of the sides are congruent. So it's similar to a square. All of the sides are going to have the same measure. We also have that the diagonals bisect the angles they pass through. So these are going to be bisected into 2 congruent parts. So they're going to be opposite and they're going to be bisected. And then we know that the diagonals are perpendicular bisectors of each other. So the diagonals are bisected again. And because they're perpendicular, they're going to create right angles in the center. So let's use that information to answer some questions. So in number 7, we want to find all of the angles. So as we just said, we know that they are perpendicular diagonals. So we have 90-degree angles at all of the centers. We also know that the opposite angles are bisected. So they're all going to be congruent. So if this part is 24, they're all 24. Then to find our last angle, we can do 180 minus 90 minus 24 to get that these bisected angles are all going to be 66 degrees. In number 8, we want to solve for x, y, and z. So we know that BEC is z squared plus 3z plus 50. BAE is 5x plus 6y. DAE is 39. BC is 4x minus 2y. And CD is 4. So first let's solve for x and y using our system. We know that all sides are congruent. So 4x minus 2y is going to equal 4. We also know that the diagonal bisects the angle. So we have 5x plus 6y is equal to 39. So in order to solve, I can multiply the first equation by 3. 12x minus 6y equals 12. 5x plus 6y equals 39. So we get 17x is equal to 51. X is equal to 3. Once we know x is 3, we can substitute 4 times 3 minus 2y equals 4. 12 minus 2y equals 4. Negative 2y equals negative 8. So y is 4. So we have 3, 4. We also know z squared plus 3z plus 50 has to equal 90 degrees at the center of the rhombus. So we can move the 90 over. Z squared plus 3z minus 40 is equal to 0. So we need two numbers that multiply to negative 40 and add to 3. So we have z plus 8 and z minus 5 is equal to 0. So z is negative 8 or positive 5. Our last special type of parallelogram then is a square. So a square has every property that we have talked about so far. So in a square, it's going to have 4 congruent sides. It's going to have 4 right angles. The diagonals are going to be congruent and bisect each other. And they're going to be perpendicular to each other. So if we are finding all the angles in a square, they're always going to be the same, so they're not going to give us an initial angle. So in a square, we know that the diagonals are perpendicular to each other, so it creates all of the right angles. And then we know the opposite angles bisect these right angles in the corner, so they are all going to be 45s. In number 10, solve for x and find the perimeter. So from a rhombus, a square gets the property that all sides are congruent. So we have x squared minus 35 equals negative 2x. X squared plus 2x minus 35 equals 0. So we need two numbers that multiply to 2 and multiply to negative 35 and add to 2. So we would have x plus 7 and x minus 5 is equal to 0. So x is negative 7 and x is 5. Now, when we go to substitute, if I put in 5, negative 2 times 5 doesn't give me a positive side. So I'm going to cross that out. I'm just going to use negative 7. So negative 2 times negative 7, or negative 7 squared minus 35, gets us the same thing. All sides of the square are 14. So our perimeter is 14 plus 14 plus 14 plus 14, or 4 times 14, which is 56. Now, our next two shapes are not parallelograms, remember. So they are not going to have any of the initial properties. They're all going to have unique properties to themselves. So in a kite, we have two disjoint pair of consecutive sides congruent. This means that they are next to each other to be congruent. So here's two sets of sides that are congruent in a kite. The diagonals are perpendicular. So they are going to create a right angle. One diagonal bisects the other. So the longer diagonal is always going to bisect the shorter diagonal. The diagonal that goes to the angles that's between the two different side lengths, that's the one that's going to be bisected. One diagonal bisects a pair of opposite angles. So the angles that are between, that are shared or included by the congruent sides, those angles are going to be bisected. And then the opposite angles, the other two, are going to be congruent to each other, but they are not going to be bisected. So let's use the kite to find these properties. So in number 12, we want to solve for x. The measure of k and L is 8x minus 2. Well, we know that all of these angles at the center are 90. So we have 8x minus 2 is equal to 90. So we can add 2x equals 8x equals 92. So when we divide, x is 11.5, or we can say 23/2. In number 13, find the perimeter of kite JKLM. So we know that these two sides are going to be the congruent, and these two sides are going to be congruent because one is shorter and one is longer. So JM is 10, which means JK is also 10. KL is 14, so ML is also 14. So if we're looking for our perimeter, 10 plus 10 plus 14 plus 14 is going to give us a length of 48. In the last one, number 14, find all measures of the kite angle MLK. So this angle is 13 degrees, and JML, this whole angle is 109 degrees. So if I know that this is 13, it's bisected, so both of them are 13. If we have 13 and a 90-degree angle, we can subtract from 180 to get this angle is 77 degrees, this angle is 77 degrees. Now, if we know that the whole larger angle by M is 109, we can do 109 minus 77, which is 32 degrees, which is the same thing up here. And then I can subtract 90 and 32 from 180 to get that these other bisected angles are 58. Our last shape then is an isosceles trapezoid. Now, remember that we do have regular trapezoids, but their properties in a regular trapezoid aren't all that useful. All we know is that one set of base angles is parallel, or one set of bases is parallel there, and we know that the angles from each base are supplementary. But isosceles triangle opens up a lot more windows for us to do things. So in an isosceles triangle, just like an isosceles trapezoid, your legs are congruent. The bases, the other two sides, are going to be parallel. So you don't have them both congruent and parallel like you do in a parallelogram. So that's a big difference. A trapezoid only has one set of parallel sides. The upper base angles and the lower base angles are congruent. So just like an isosceles triangle, your base angles are going to be congruent, but this time we have two bases. We also know that our diagonals are congruent. And the lower base angles are supplementary to the upper base angles, which makes sense because of the parallel lines. So these are same side interior angles. So let's use those properties to answer a few questions. So in number 15, we want to find the missing angles. Well, we see that these legs are congruent. So these angles are both going to be 100. Then we know that BC and AD are supplementary to each other. So we can subtract from 180 to get both of those angles are 80 degrees, which they should be the same. In 16, we want to solve for x and find all of the angle measurements. So we know here that, again, we have an isosceles trapezoid, so our base angles are congruent. 6x plus 6 is equal to 5x plus 18. So when we solve, we get x is 12. Once we know x is 12, 6 times 12 plus 6 is 78 degrees, so both base angles are 78. 10 times 12 minus 18 is 102. Same thing if I did 180 minus 78, I'd get these angles are both 102. In our last problem, AC is x squared plus 5x. BD is 2x plus 18. AB is 7y minus 2, and CD is 26. So we know our diagonals are congruent, so x squared plus 5x is equal to 2x plus 18. X squared plus 3x minus 18 is equal to 0. So we need two numbers that multiply to negative 18 and add to 3. So we get x plus 6 and x minus 3. When we switch our signs, x is negative 6 and x is positive 3. We also know that the legs are congruent, so 7y minus 2 is equal to 26. 7y equals 28, so y is 4.